Welcome to Evidence Mastery. Today, we're diving deep into an explainer based on Dr. Masoud Tusi's fantastic book, Real-World Evidence, Principles and Practice. We're going to be unpacking Chapter 7, which tackles two of the absolute biggest challenges in healthcare research, bias and confounding. These are the invisible forces that can completely undermine a study's credibility. So if you're ready, let's get right into it.
So here's our game plan. First, we'll set the stage and look at why this is such a major challenge in the first place. Then we're going to unmask the two big culprits, bias and confounding. Once we really understand what we're up against, we'll talk about a framework for designing truly rigorous studies. And finally, we'll see how all these ideas play out with some fascinating real-world examples.
So let's start with the big question. Why does this matter so much? Well, real-world evidence, or RWE, is totally essential. It's what we use to make critical healthcare decisions every single day. But its very foundation, its trustworthiness, is under constant threat from bias and confounding. Honestly, for anyone working in this space, getting this right isn't just important, it's everything.
And to really get a feel for the challenge, just think about the difference between RWE and what we often call the gold standard, randomized controlled trials. You see, RCTs have these beautiful built-in protections like randomization, but in the messy real world, we just don't have that luxury. We have to be clever. We have to rely on really smart design and sharp creative analysis to be confident in our findings.
Okay, let's take on our first adversary, bias. The best way to think about it is like a thumb on the scale. This isn't just a random mistake here or there. No, this is a systematic problem that is constantly pushing our results away from the actual truth.
Here's the more formal definition you'll find in the book. Bias is any systematic deviation from the truth that crops up because of flaws in how we design a study, collect the data, or analyze it. But that word systematic is the absolute key. We're not talking about a fluke. We're talking about a repeatable error that's baked right into the process, always nudging the results in a misleading direction.
And, bias isn't just one single thing. It actually comes in a few different flavors. The book groups them into four big buckets: bias in how you select people for your study, bias in the information you collect, tricky issues related to time, and finally, bias in how you run your analysis. We're going to zoom in on a couple of key examples from those first two categories.
So first on our list is selection bias. This is all about who makes it into your study. If the group you're studying doesn't really reflect the larger population you want to draw conclusions about, well, your results are going to be skewed before you've even started your analysis.
And this is where things get really subtle and, honestly, kind of sneaky. Take a look at immortal time bias. I mean, it sounds dramatic, and for good reason. Imagine you're studying statins after a heart attack. A patient has to first survive long enough to even get the prescription filled. If you mess up how you account for that waiting period, you can accidentally make the drug look like it has a miraculous protective effect that isn't real. It's a really subtle but incredibly powerful flaw.
Next up is information bias, which is all about errors in the data itself. And with new technology, we're facing brand new challenges. For instance, we're now using AI to sift through mountains of health records. But this can lead to something the book calls algorithmic hallucination bias. Basically, the AI can invent a clinical history for a patient that seems totally plausible, but is completely made up.
Wild, right?
Okay, time to shift gears and talk about our second major threat, confounding. Now, this one's different. Unlike bias, which is an error that we introduce, confounding is a real relationship that already exists in the data. It's like this tangled web of cause and effect, and our job is to carefully unravel it.
So what exactly is a confounder? Well, think of it as a third variable, a third wheel that's connected to both the thing you're studying, which we call the exposure, and the result you're measuring, the outcome. This third wheel gets in the middle and distorts the relationship we're trying to see, making it look like there's a link when there isn't, or hiding one that's actually there.
The absolute classic example that everybody in this field knows is the story of hormone replacement therapy, or HRT. Early studies seem to show that HRT was amazing for preventing heart disease, but it turned out to be wrong. Why? The results were confounded by socioeconomic status. The women who were taking HRT tended to be wealthier, more educated, and had healthier lifestyles to begin with. It was that background, not the drug itself, that was responsible for the lower risk.
Okay, we've met the villains of our story. Now for the good part. How do we fight back? This section is all about the strategies and the tools we can use to build strong, believable, real-world evidence by tackling bias and confounding from the start.
We can think about our defense in 3 stages. But here's the most important thing to remember. The design phase is number 1 for a reason. It is, by far, the most critical stage. You can have the most brilliant statistician in the world, but they can't save a poorly designed study. Quality has to be built in from the ground up.
So let's talk about some powerful design choices. We can actually design our studies to be way more robust right from the start. For example, using a new user active comparator design is a great move. It means we only look at patients who are just starting a treatment, and we compare one active drug against another active drug, instead of against a do-nothing group. This simple choice helps make the 2 groups way more comparable from day 1.
Then, when we get to the analysis phase, we have some amazing tools at our disposal, like propensity score matching. You can think of this as a kind of statistical matchmaking. We calculate a score for every patient based on all their characteristics, and then we match people from the 2 different treatment groups who have a very similar score. What we're doing is creating 2 new groups that look almost identical, essentially mimicking the magic of randomization after the fact.
And we can even do a stress test on our findings to see how robust they are against confounders we didn't even measure. That's where something called the E-value comes in. Look at this example. Say we found that a drug doubles the risk of an outcome. The E-value tells us just how strong a hidden confounder would have to be to completely erase our finding. In this case, it would need an association of at least 3.4 with both the drug and the outcome. It's a fantastic way to quantify how confident we should be.
All right, theory is one thing, but let's see how all of this actually works in the real world. We're going to quickly run through 3 case studies from the book that really showcase these rigorous methods in action.
These examples really show the breadth of the toolkit. When the FDA was studying NSAID safety, that strong new user design we talked about was the absolute key to getting a reliable answer. For a dermatitis drug study in Europe, the researchers had to use advanced statistical models to deal with confounders that were changing over time. And in a Canadian study on air pollution, they threw multiple sensitivity analyses at the problem. They even compared siblings to control for genetics and upbringing, all to make their conclusions as solid as possible.
So what's the big picture here? What's the main takeaway? I think this quote from the book captures it perfectly. In the world of real-world evidence, we are not chasing some impossible dream of absolute certainty. The real goal is what's called calibrated confidence. That means having enough solid evidence to make a good decision right now, while always being humble enough to change our minds when better evidence comes along.
If this has sparked your curiosity and you want to truly master these concepts and get a much deeper look into the science and strategy of real-world evidence, the entire chapter and so much more is waiting for you in Real-World Evidence, Principles and Practice by Dr. Masoud Tousi. You can find it right now on Amazon.com. Thanks so much for watching.